Okay, friends, sad but true, this is our last section of trig functions in Math 12. We are not looking at the tangent functions in 2022, but we'll likely be looking at them in 2023 due to COVID. So let's take a peek at modeling part 2. This is the last section, and there's a lot of great questions in there for you to practice. There are a bunch of questions in here that are not in the slide deck, so make sure you do them. Good luck. So we're going to look at our last section here, which is modeling contextual problems part 2. And so you can see that we've been through all the sections here, but we are going to pass on this section this year. Okay, so here we go. So today we're going to be talking about harbors and safe harbors. There's some great video clip here for you to take a peek at in the slide deck. So please click on that to take a look. Is it safe to anchor overnight? That's the question. Some tides go up and down so high that you could be left on a rock if you don't get out in time. So here's the situation today. What time should a boat leave for deeper waters? The sailboat information, given that the boat's underwater geometry risks damage in water less than 9 feet, and it says that the boat anchored at 9 p.m., 4 a.m. is at a high tide, and 4 p.m. is a low tide. Let midnight be time 0. So what I'd like you to do is pause the video and take 10 to 20 minutes on this problem, and then press play, and we'll check in. Alrighty. So if you got 11:34, you are in great shape. That's exactly what time you need to leave to be safe, or before that. And so if you're not sure, let me help walk you through it. So here's the information here, and so I'm going to get you started. So the first thing that I'm going to do is it tells us that we have a high tide at 6 let's see if we can get that. We have a high tide. I'm going to hide that piece. So we have a high tide at 4 a.m. and it's 16, and then we have a low tide of 6 meters at 4 p.m. And notice that I need to add the 12 to it to get to, so 16 represents 4 p.m. Then we're going to draw the vertical displacement, which is going to be halfway in between 16 and 6, which happens at 11 meters. And then what we're going to do is we're going to draw the sea floor, so it's down there. So if I were beginning to draw an equation, let's do a cosine wave. So what I want to do is I'm going to go 2 pi divided by something, and let's not forget our phase shift. Let's also get, actually maybe what we'll do, let's get the vertical displacement in there, and the vertical displacement is plus 11, which means that the amplitude is 5. Alrighty, and I'm just gonna, for funsies, I'm gonna put a little x in there. And I'm also going to determine, I guess I need to determine what the period is. So let's keep on going. So it appears as though it is taken between a high tide and a low tide. It looks like it's taken 12 hours. So that must mean that to get up to the next high or low, it's going to take another 12 hours. And I could probably do that on both sides. And then from there, I could figure or deduce that the period must be 24 hours. So if I put a little 24 in there, I get that, and I notice that there's been a phase shift. So let's see if I can figure out how to do that. Well, but notice this, look at this. So the high tide is happening at 4 a.m. So what I want to do is write in the line, the y-axis, which is going to be at midnight. And that was part of the problem. We assumed that. So I can see that it has been shifted over a certain amount, and that certain amount, to me, sure looks like a phase shift of -4. So if we shift that over x -4, then we get our wave. So there you go. Now, if we wanted to determine, draw the water line at 9, so I'm going to do this, which I've done. So y equals 9. Notice that when I do that, I'm going to hide some of this other information here. So basically what we're going to do is just figure out what time that is. And that looks to be about, why is this having trouble? It's not liking that at all. I'm not sure why it's not liking that. So that point right there, when that's exactly 9, It looks like 11.57. So what we want to do is convert that to hours. We know it's at 11, and then what we do is we take 0.57 and multiply that by 60. And when we do that, we're going to get our 11:34, which is the time we need to leave by. Alrighty, this is another great challenge because it's very wordy and it's really testing your vocabulary. So can you understand the vocabulary? That's what this question is asking. So pause the video, put a good 10 to 20 minutes into this problem, and then check in. Okay, the answer to this one, first off, it says f of x equals g sine mx plus n. All these are positive constants. Determine the smallest positive value of x that produces the largest value of f of x. So here we go. So what we're going to do, I'm going to help you with this. Here's a basic sine wave. It looks like this. And what I've taken the time to do is I've just said, hey, I've arbitrarily said that it's moved up n, which means that the maximum height happens at n plus g. Now notice that this n does not change where the maximum is. It just means that it's higher or lower, but the maximum would always be here. So that means that the g and n don't really impact where the maximum is. The only thing that impacts where the maximum is this m value. But here's what you know. You know that the period of a sine wave is usually 2 pi. So that would mean here that this period would be 2 pi over m. And so if this has been divided by m, then guess where that is? Usually it's at m, but now it's going to be at pi divided by m. And if this is usually at pi over 2, well, now it's going to be at pi over 2 divided by m, and that's why we have pi over 2m. If we were to put this value back in right up here, can you see that the m's would cancel? And I just basically have pi over 2. And that's the solution. And that's where we got pi over 2m. So I hope that helps. And we are closing down trig. We are done for now.